Dear students, the today topic is AC transient. The before already discussed the DC transient for RL, RC and RLC circuits. The similar to this AC transient circuit, the AC transient circuit, the RL series circuit first. The consider the series RL circuit. Draw the source, switch and resistance and inductance. The current flow is the transient current I of t. The source is the before the DC circuits only from the E. The applied voltage is E. The applied source is E of t is equal to Em sin omega t. With the alternating current with respect to the time, the frequency, the time and the frequency. Upon the applied the AC source, the current flow through the resistance and inductance, the passing the current is I of t. At the time t, the switch will be closed at the time is 0. When the switch is closed at the time t is equal to 0, let I of t be the current flowing through the circuit. The step 1, by applying Kirchhoff's voltage law. The Kirchhoff's voltage law, the applied voltage equal to potential drop. The applied voltage equal to potential drop. This is the first that the potential drop R into I of t plus L into d I of t divided by dt equal to applied voltage E of t. Or I of t plus L into d I of t, the E of t is equal to Em sin omega t. Step 2, the taking Laplace transform. R into I of s plus L into S into I of s minus I of 0. This value is the initial value. This equal to E sin omega t. Em sin omega. This Em is the constant value. The sin omega t is the Laplace, taking the Laplace transform is omega divided by s square plus omega square. Assume the initial current I of 0 is equal to 0. Or I of s plus L into S into I of s equal to Em omega divided by s square plus omega square. I of s, take the outside is I of s, R plus Ls equal to Em omega divided by s square plus omega square. The I of s is this side, to remaining value is the other side. Em omega divided by L divided by this terms is dividing 2. This is R plus Ls. Ls is equal to, take the R by L is outside, 1 plus S. This is S square plus S plus R by L. R by L is the outside, R by L. The step 3, applying the partial fraction method. The partial fraction method to the right by Em omega L divided by S square plus omega square into S plus R by L. This is the dividing in 2. A divided by S plus R by L plus Bs plus C divided by S square plus omega square. Omega square. This value is the cross multiplication. To multiply in the cross multiplication by Em omega square omega divided by L into S square plus omega square into S plus R by L. This is the cross multiplication. A into omega square plus omega S plus S square plus omega square plus BSC into S plus R by L. But this value is the common term is cancelled. By Em omega divided by L equal to A into S square plus omega square plus Bs into S plus R by L plus C into S plus R by L. Put S is equal to minus R by L. Em omega L A into R square by L square plus omega square. This substituting the values of A value. To find out the A value is equal to Em omega L divided by Z square. Divided by Z square, R by L. Omega is the Z, then is Z square. Next, substituting the B. Next, the B is same and C is equal to the roots of this value. But the partial fraction method. The step 4 take place. That step 4, the taking the inverse Laplace transform. Inverse Laplace transform I of t is equal to omega L into Em divided by z square e to the power of minus r by L into t minus omega L Em divided by z square cos omega t plus r Em divided by z square sin omega t. Take the outside is this is the first term. The second line is Em divided by z square is the common term. It's outside r sin omega t. R by sin omega t plus omega L into cos omega t. This is that RL circuit. The second one is, the next topic is RC series circuit. Consider this circuit. This one is the voltage source, switch R and C. The continuous series, the current passing through the I of t. And S is switch at the time of switch at the t is equal to 0, close the at the time of 0. The same, the source is Em sin omega t. Then the applied step 1 is by applying the Kirchhoff's voltage law, or I of t plus 1 by c. The capacitance will be connected is the integration, and the inductance is the differentiate is the capacitance is the 1 by c, the integral part. The 1 by c is integral of minus infinity to t I of t into t dt sin omega sin t. This is the splitted in the integral part, the initial value and the charging value. The initial is 0, the minus infinity to 0 is the initial value, 0 to t is the charging time. The initial value is 0. To assume the initial value is 0, up minus infinity to 0 is the 0. Assume up r I of t plus 1 by c integral of 0 to t I of t into dt equal to Cm sin omega t. Step 2, taking Laplace transform, or I of s plus I of s divided by Cs Em omega divided by, this is the sin omega t is equal to omega divided by sin square plus omega square. Take outside of I of s r plus 1 by Cs Pm omega divided by s square plus omega square. That I of s is the LCM of these values of r plus 1 by Cs. Cs is RCS plus 1 divided by Cs. This is the next time the I of s is this side, to another values is the other side, Em omega Cs divided by RCS plus 1 into s square plus omega square. This RC is the outside. RC is the outside. S plus 1 by RC, s square plus omega square. CC is cancelled. S divided by R. Then this values of Em divided by R into omega into S. This value into S plus 1 by RC, S square plus omega square. Apply the next step 3, applying the partial fraction method. Apply the partial method is same of A divided by S plus 1 by RC plus BS plus C divided by S square plus omega square. This value is Em, this value is applied in this, the cross multiplication to cancel these values to same values of applying A is equal to Em omega C Z square, B is equal to minus Em omega C Z square, C is equal to Em omega square C square Z square minus 1 divided by omega R C square into Z square. This omega R Em divided by Z square. This value, the I of s is equal to A value, the substitute here, Em divided by omega C square 1 by divided by S plus 1 by RC. B is equal to Em divided by omega C Z square into S divided by S square plus omega square, and C is equal to R Em divided by Z square. This is the taking the inverse Laplace transform. The next step 4, taking inverse Laplace transform. I of t is equal to minus Em omega C Z square into e to the power of minus 1 by RCT plus Em divided by omega C Z square into cos omega t plus R Em divided by Z square into sin omega t. That's all. The next topic is RLC circuit. The RLC circuit, consider in the RLC and the source and the switch will be connected in series. At the time of t is closed, the I of t, the current, the transient current passed through the RLC. This is when and the t is equal to 0. Step 1, applying the Kirchhoff voltage law. And the same procedure, the Kirchhoff voltage law is a potential drop equal to applied voltage. The applied voltage, the potential drop is R into I of t plus L into d I of t divided by dt plus is the integral, the capacitance is integral part 1 by c into integral of minus infinity t I of dt into dt equal to Em sin omega t. Take the initial, the both side is the initial values, the inductance and capacitance, the initial values are 0. The initial values are 0. They are taking the Laplace transform I R into I of s plus L into I of s into, this is the inductance initial value, I of 0 is 0, I of s is equal to 0. Then the R into I of s plus L into S into I of s plus I of s divided by C is E m omega divided by S square plus omega square. This value is I into C. The take the outside is I of s. The R plus L S plus 1 by Cs. This value is the voltage source is constant. I of s. But when the LCM, take the LCM values RCS plus LCS square plus 1 divided by Cs. This value is I of s is the this side. Remaining values is the other side. Em omega Cs divided by S square plus omega square into RCS plus LC square plus 1. This is the Em divided by, this value is the equation, Cc is the cancel. Take the outside of LC, LC is the LCC is cancelled. This values of omega Em divided by L into S, up S square plus omega square into S square plus R by L S into, this is the second order equation. But the quadratic equation, this root, the roots of the quadratic equation can be the following three types. One is the real and the equal roots, real and unequal roots, and complex conjugated roots. These are three types. One is the real and the equal roots. The equation 5 that can be written as omega Em divided by, into S divided by L, S square plus omega square into S plus A whole square. A divided by S plus A, B divided by S plus A whole square plus Cs plus D divided by S square plus omega square. This root, therefore, the transient current is I of t is equal to A into e to the power of minus at plus B into t into e to the power of minus at plus Im sine of omega t plus or minus pi is the angle. Next one is second, the real and the unequal roots. The equation 5 can rewritten is the same values the first equation. Second, the I of t current is A into e to the power of at, B into e to the power of minus b t plus Im sine into omega t plus pi. The second one is the complex conjugated roots. The equation 5 can be written as, this one is the complex conjugated roots. The dividing the both the previous two steps, equal and unequal, this one is As plus B, Cs plus D. This is the complex conjugated by S plus A whole square plus omega D square. This one Cs T plus S square plus omega square. This is therefore I of t current is I naught e to the power of 18 to sine omega d dt plus theta plus Im sine omega t plus or minus pi. This one is for the transient response of the AC circuit. The three types, one is the RL circuit, RC circuit and RLC circuit. The same derivation they using the applicable in the problems to substituting in the resistance value, inductance value and capacitance value. At that time t is equal to 0, put in the derivation, the answer is taken. Your assignment to work out the already the submitted the notes, the problems is there to work out the problem in the related derivations and DC circuits and AC circuits also, and the related problems work out. The any other doubt means to call me to undoubt clear students. To your understanding the transient circuit, the transient circuit is the switching devices. The current is suddenly changes, or voltage, current or voltages suddenly changes. The speed is called as a transient period. Okay, these are the two types. One is DC transient and the AC transient. The DC transients, the common from RL, RC and RLC, and AC transients the same for the RL, RC and RLC. The three derivation, totally the 6 derivations in the unit. To the compulsory any two derivation or DC or AC, the end semester definitely to ask the questions for any two derivation. To your workout the repeated in this derivation, the concept is very understand only for this your Kirchhoff's voltage law. Your main thing is the Kirchhoff's voltage law and Laplace transform, the Kirchhoff's voltage law and Laplace transform and Laplace inverse. The three applications is implemented in this unit is very simple, is very easy. You understand, you repeatedly is the derivation is the workout and implemented the problems to substitute the values in the derivation R, L and C. Substitute the values and work out the problems. Okay, you are any doubt to ask me. Thank you.